Since the beginning of the space age, mankind has developed many new technologies to help better study the universe, our galaxy, the solar system, and look for evidence of extraterrestrial life. Look at this tiny pinhole of light in space. That's us. That's planet Earth. On August the 25th, 2012, 35 years after it was launched, Voyager 1 left our solar system. On its way out, it snapped a photo of the Earth from 3.7 billion miles away before turning off its cameras to conserve power. Now it's reached interstellar space, and after 43 years and 4 months, the spacecraft still communicates using the Deep Space Network. But Voyager 1 found that interstellar space is a lot weirder than we thought. What have we discovered, and why is it so important? In the summer of 1964, NASA developed ways to study the outer planets of the solar system in the NASA Jet Propulsion Laboratory. Engineer Gary Flandreau predicted that by the end of the 1970s, there'd be a rare alignment of the planets Jupiter, Saturn, Uranus, and Neptune that only occurs once every 175 years. This alignment of the planets would allow mankind to visit all 4 planets during a single mission. The flight would change its trajectory at each planet and increase the speed of the probe enough to reach the next point in its flight path. Gravity maneuvering, or slingshotting, is when a spacecraft is pulled by a planet's gravity and increasing speed as it shoots around the planet, saving tons of energy and time. As an example, flight to the farthest planet, Neptune, could only take 12 years instead of 30. The Mariner Jupiter-Saturn project began in early 1972 at a cost of $360 million. In March 1977, just a few months before launch, due to the mission's importance, the probes were renamed Voyager 1 and Voyager 2. The Voyagers were equipped with computers that could be reprogrammed, allowing researchers to change programs and fix any problems on the fly. On August the 20th, 1977, Voyager 2 was the first sent into space, 16 days before Voyager 1 would be launched. But because it was on a trajectory that took longer to reach Jupiter and Saturn, Voyager 1 would eventually pass it. Since 1962, there's been interplanetary missions to study Venus, Mars, and Mercury, with missions lasting up to 3 years. But the probes would need to last long enough to be part of the Grand Tour project at NASA, which needed 2 probes to study the 4 gas giants Jupiter, Saturn, Uranus, and Neptune. But it was later suggested that Voyager 1 and 2 visit only 2 planets. Information in the press spread saying that only Jupiter and Saturn would be visited, reducing the overall cost of the project. Experts looked at over 10,000 trajectories before they chose 2 that would allow them to fly by Jupiter's largest moon, Io, and then Saturn and its largest moon, Titan. This route also gave the spacecraft the opportunity to continue towards Uranus and Neptune. The thought of extraterrestrial civilizations intercepting these probes was on the minds of researchers. American astronomer Carl Sagan, along with his team, created a golden record, with 115 images encoded in analog form, spoken human greetings in 55 languages, a variety of natural earth sounds like wind and thunder, sounds of animals like birds and whales, and different music from around the world.
Hello from the children of planet Earth.
Which probe made the first planetary mission? The original mission plan was for the Voyagers to operate and last only 5 years. It would be long enough for them to study Jupiter, Saturn and its rings, and the 2 planets' largest moons. However, as the mission continued, the ambitions of scientists grew, and the Voyagers outperformed well beyond what was expected. On March the 5th, 1979, Voyager 1 was 173,983 miles away as it approached Jupiter and was able to snap images of its moons Io and Europa. And although Jupiter has been one of the most studied planets in our solar system, new photographs gave researchers unseen angles and more information about these planets as if they were new worlds. The new images of Jupiter's closest moon, Io, had yellow, orange, and brown surface colors, showing scientists evidence of volcanic rock. At least 8 active volcanoes were spotted on Io, shooting material into space, and stunning images of this were captured when Voyager flew by. Io turned out to be the most volcanically active body in the solar system. A little over a year after launch, Voyager 1 approached Saturn on November 12, 1980. Expectations were greatly met, and researchers were able to expand their understanding and knowledge of Saturn. 3 new moons were discovered: Prometheus, Pandora, and Atlas. But the biggest accomplishment was getting new information about Saturn's largest moon, Titan. It's the only moon in the solar system that has a thick atmosphere. Similarly, it was discovered that the upper layers of Saturn's atmosphere consists of 7% helium, and the rest is hydrogen. Voyager 1 also discovered Saturn's G-rings, disc-shaped plains made of ice and dust. Another interesting discovery was Saturn's 6th largest moon, Enceladus, which was found to reflect more solar light than any other object in the solar system because of the fresh, clean ice covering its surface. Images were captured that showed its crater-ridden landscape, indicating some geological activity under the surface that could be a source of heat for a liquid ocean. But Voyager 2 was about to make some discoveries of its own. On July 9, 1979, Voyager 2 made its closest approach to Jupiter and snapped this amazing photo of Jupiter and its moon Io, casting a shadow on the gas giant. On August 25, 1981, after successfully arriving at Saturn, the probe snapped images of the gas giant's rings and moons. It was clear at this point that Voyager 2 could now fly to Uranus with all its instruments remaining functional. NASA asked for more money and instructed the NASA Jet Propulsion Laboratory to extend the Voyager 2 mission to Uranus and Neptune. On January 24, 1986, the Voyager 2 probe approached Uranus at a distance of 50,600 miles above the icy cold cloud tops and gathered data that revealed 2 new rings, 11 new moons, and recorded the surface temperature of Uranus at a chilly -353 degrees Fahrenheit. Uranus rotates at an angle, and its magnetic field is displaced from the axis and plane that all other planets are found in. The data also showed that both of Uranus's poles have the same temperature, although only one receives sunlight. Researchers figured the planet must spread temperature in different ways. Recently, researchers were going over the decades-old data and studying the 45-hour convergence of the probe and Uranus when they noticed a 60-second jolt in its magnetic recording. It was discovered that Voyager 2 flew through a plasmoid, a giant magnetic bubble that might have been carrying the atmosphere of Uranus out to space. Actually, all planets leak atmosphere into space, and even Earth's atmosphere does the same thing. But don't worry, we have enough atmosphere to last billions of years. When Voyager 2 approached Neptune, researchers didn't think they'd see anything other than darkness. NASA crews increased the size of Deep Space Station's radio antenna in Canberra, Australia, to catch the incredibly weak radio signals that the probe was relaying from Neptune. On August 25, 1989, Voyager 2 was 30,000 miles away from the 8th planet in the solar system. Approximately 30 times farther from the Sun than the Earth, Neptune receives only 0.01% more sunlight than the Earth. In almost complete darkness, Voyager 2 started taking mysterious photographs. They revealed the makeup of the blue planet, showing the presence of methane, 6 new moons, and 4 rings. Like Saturn and Uranus, the rings and Neptune's 4 moons made a complex, interconnected system. The probe also discovered winds measuring 1,500 miles per hour around a strange, previously unseen place on Neptune named the Great Dark Spot, a massive rotating storm the size of the planet Earth. In fact, both planets, Uranus and Neptune, are known for strong winds that can reach supersonic speeds 10 to 15 times stronger than on Earth. Uranus and Neptune were originally thought to be gas giants, but in the 90s it was discovered that they were made up of heavier substances, and they became a distinct class of planets called ice giants. Triton was no less impressive. This moon of Neptune is located to the planet's north. It's the coldest of all natural bodies astronomers have discovered at a frosty -391 degrees Fahrenheit. Voyager 2 was able to approach the planet at a distance of about 25,000 miles and discovered active geysers that spewed nitrogen into space. Triton was the final object that the space probe would meet in the solar system before heading out into the great unknown. Where will the Voyagers go next? The Voyager's interplanetary missions have been completed, providing astronomers with lots of new knowledge and a better understanding of our solar system. These two probes, together, made huge breakthroughs in astronomy. Distant object in space made by humans, and Voyager 2 was the first to study the 4 outer planets, Jupiter, Saturn, Uranus and Neptune, and also entered interstellar space in November 2018. But when Voyager 1 went into interstellar space, the instrument that measures the temperature of plasma had stopped working, but Voyager 2 still had a working instrument. Our Sun does a lot more than just provide light and warmth. The entire solar system is moving through space and is surrounded by a bubble called the heliosphere. This bubble is continually inflated by plasma coming from the Sun and is known as the solar wind. It extends 11 billion miles from the Sun's leading edge, surrounding all 8 planets and beyond. And a good thing too. Outside the heliosphere, in interstellar space, radiation levels and cosmic rays are a lot higher than inside the bubble. The Sun's solar winds are protecting the entire solar system as it flies through space. The heliosphere extends far beyond the region of Pluto until it encounters what is called the termination shock, where its motion slows abruptly because of the outside pressure of the interstellar medium. Voyager 2 discovered that the interstellar medium was at least 54,000 degrees Fahrenheit, but the plasma is so thin and diffuse that the temperatures around Voyager 2 remained extremely cold. The Voyagers have started supplementary missions to study the outer regions of the solar system in interstellar space. These two probes are still speeding across interstellar space and will never return to the solar system and only have the infinite reaches of space ahead of them. NASA's website shows where the Voyagers are in real time. They're getting further and further away from the Earth, every day letting us know we could expect the unexpected. Our friends over at Channel Perception just released a cool new video about NASA's plan to stop an asteroid. We thought it was really awesome. So, you should go check it out. We think you'll enjoy it.